This is for Year 12 Methods. It's question 8 in the 2012 Tech Allowed Diff test, and it's the open rectangular box. Okay, if it was 25 by 18, therefore the height's going to be x, 18 minus 2x, 25 minus 2x, label the sides for marks. Show that an expression for the volume is this, length times width times height. In my showing, you need to expand by hand. Can't do anything on calculator in a show question, and you need to actually do the calculations. Part C, find an appropriate domain. If you look at the three edges of the box, x has to be greater than or equal to 0. This one tells you that x has to be less than or equal to 9, otherwise you'd get a negative, so x less than or equal to 9. And this one tells you that x has to be less than or equal to 25 on 2. All of these intersections, therefore x has to go from 0 to 9. Part D then asks, state the exact value of x that gives the maximum volume. Okay, on my calculator, I'm going to put in my expression for volume, which is x 18 minus 2x, 25 minus 2x, and I'm going to take the derivative, calculate derivative with respect to x. I'm going to set it equal to 0, and I'm going to solve for x, which gives me two expressions, 43 on 6 plus or minus 499 on 6. Now, those two answers I'm going to double check and see which one sits between 0 and 9, and it's this first one. The second one is 10.9, and that's outside my domain. So I'm going to be looking for 43 on 6 minus the square root of 499 on 6. State the volume. So if I take my expression for volume, and I put that in a new line, and I go option given x equals this, which is the option that I'm looking for, that gives me an expression that's pretty awful, so I might take that expression and I'll go to transform and simplify, and there's a much nicer expression. That's the exact form, that's the decimal form. It's set to 2 decimal places, so 693.14. Show that the surface area of the box is this. Remember, it's an open box, so there's only going to be one of 25 minus 2x times 18 minus 2x, it's at the bottom, but there's going to be two of these and two of these. Expand it, simplify gives you that. The domain's going to be identically the same for the surface area as it is the volume. And find the surface area of the rectangular box that has the largest volume. Well, I know that the surface area is 450 minus 4x squared, and I know that the largest volume is when x equals this. So when I go back up and find that x value, when x equals this, that's going to be the largest volume. So if I substitute for x equaling that into my surface area expression, that gives me my largest possible surface area. And I might go into a new line, interactive transform, simplify, and there's a much simpler form for it. And 402.57 is going to be my answer.